now that we understand a little bit about these formulas, let's see how we can actually use them. So here's a partially worked problem, but let's see how we can figure this out and maybe finish the rest of it. So given this formula, how do we know that it's horizontal? Well, this is a horizontal ellipse because look at where the largest denominator is. It's with the x. So larger denominator with the x means that it's going to be horizontal. Also, the center, we're going to get the center values from the numbers next to the x and the y. So because this is a positive 2, we're going to put negative 2 here. Because it says minus 4, we're going to put a positive 4. That's how we're going to get the center. Whenever it's horizontal, that means that we're going to take whatever the center numbers are and we're going to focus on the x value. So notice that we're representing the x value with h. So for the center, whatever h is, we're going to add on this a value. We'll see what that is. And then we'll keep this k value the same. So in the case of what we have here, a squared is always going to represent the larger number. So a squared is 25. That means to get a, we have to take the square root of this number. So basically take the big number, take the square root, that's going to give you a. So square root of 25 is 5, so a is 5. That means that we're going to add on 5 to this negative 2. When we do that, we get 3. And of course we said we're going to keep the k value the same when we're talking about the vertex for a horizontal ellipse. If we're doing the second vertex, instead of adding on the a value, we're going to subtract it. So instead of negative 2 plus 5, we would do negative 2 minus 5. That will give us negative 7. And so this is our second vertex. For the covert vertex, instead of changing the x value, it's always the opposite. So if we change the x value on the vertex, we're going to change the y value on the covertex. And if we're going to use a on the vertex, that means we're using b on the covertex. So we have negative 2 as our h value. We're going to keep that the same. The k was 4, so we put 4. Our b value, that's going to come from this 9. When we take the square root of that 9, it's 3. So we're going to take whatever the k value is and add 3 to it. So 4 plus 3. That means that we're going to end up with negative 2, comma, 7. So when we do the covertex, we're going to need to follow the same pattern, but instead of adding, we're going to subtract. So it'll be negative 2, 4, minus 3 to find that other covertex. And so we'd end up with a point of negative 2, comma, 1 for the other covertex. For the focus, this one has a little extra step to it. So there's a formula that looks a little like Pythagorean theorem. You know, Pythagorean theorem says c squared equals a squared plus b squared, but this formula says c squared equals a squared minus b squared. So we know that c squared will equal, remember a squared was 25 minus, and b squared is 9. So 25 minus 9, that's 16. And so if c squared is 16, what does that mean about c? Well, c would have to be 4, because if you take the square root of 16, it's 4. When we find the focus is always going to use the c value. So when we look at our setup, the vertex and the focus kind of go together in how we do it. So remember how we added on to the h? So for the focus, we're also going to add on to that h. So for the focus, it's h plus c, comma, k. Or it could be h minus c, comma, k. if we do that, remember our h value is -2, so we have -2 plus the c value, which we said was 4, comma the k value, which we said was 4, and it's just a coincidence that it's the same number. But in any case, when we add these, we're going to end up with +2, comma 4 for one of the foci, or for that particular focus. We're going to do the same thing, but this time instead of adding, we're going to subtract to get the other one. So -2 minus 4 and comma 4. So this is going to end up being -6, comma 4 for the other focus. Why don't you try and pause the video and see if you could do this one yourself. Alright, so what do you think? Is this horizontal or is this vertical? Notice that the larger number is underneath the y. That's going to mean that it's vertical. And if it's vertical, when we get the center, will the x change or will the y change? Remember that vertical is up or down, that's a y change. So let's get the center first. The center is going to be from these two numbers. Because that's -3, we're going to say +3, and because this is +5, we're going to say -5. So that's our h and k. For the vertex, we know that this time it's a vertical change. So we're going to add on to the y part. So it's h comma k plus a, or it could be h comma k minus a. So we're going to basically say that the h is 3, k is -5, and we're either going to add or subtract to that. And we're going to take the a value to use. Okay, so let's figure out the a value. Which one of these would the a value come from? It's going to come from the 400. So for the a value, we're going to need to take the square root of 400, which is 20. And that's what we're adding or subtracting. So if we do that, then we're going to end up with a coordinate of 3, 15, and also 3, -25. For the co-vertex, we're going to do the same thing, but remember, if the y gets changed on the vertex, what gets changed on the co-vertex? It will be the x. So it'll be h plus a certain value, or h minus a certain value, and we know that that's the b value that we're working with for the co-vertex. The k value would stay the same. So if we plug our numbers in, h was 3, we're going to add the b value, or we're going to subtract the b value. B is going to come from this 256, so b is the square root of 256, which is 16. So we're going to either add 16 or subtract 16. The y value, the k, is going to be -5. So this is going to give us as our co-vertex 19, -5, or -13, -5. Our focus, do you guys remember the formula that we're going to need to work out our c value so we can get our focus? Well, remember, it's like Pythagorean theorem, but it's a little different. So as opposed to a squared plus b squared, you're going to have a squared minus b squared when we're talking about the ellipse. So we plug in our numbers, so c squared equals, a squared is the larger one, so that's 400. B squared is the smaller one, so that's 256. If we subtract these, what do we get? we get 144. So C squared equals 144. So what does that mean about C? It means that we'd have to take the square root of this to get C. So C would be 12. Remember that the focus works kind of like the vertex. So if we're changing the y on the center to get the vertex, then we're going to do the same thing on the focus. So that means the h value is going to stay the same. So K is either going to be added with C or subtracted by C. And if we do that, this is what it looks like. So 3, negative 5 plus our C value, which is 12, or 3, negative 5 minus our C value, which again is negative 12, which is 12, I'm sorry. So if we write down our coordinate is going to end up being 3, 7, or 3, negative 17. So that's it. That's how we find the attributes of a horizontal or vertical ellipse. One other just really quick thing is if you ever see something like x squared plus y squared equals 1, and of course the ellipse equation is always equal to 1, and it's, let's say, 36 and 25 like this, then it's going to be the same thing as what we're used to up here, except that instead of the center being these two numbers, our center on this one would be 0, 0. Also, another way that they might trick you in this particular example is if you had something like, let's say, 9x squared plus 3y squared equals 27. So what we would do in this case is we would just need to make sure it's equal to 1. So if you ever see anything like this, that's what you'd have to do. And what would happen next is this would divide and you'd have x squared over 3. This would divide and you'd have y squared over 9. And then this would divide and that would be 1. So you can always change these kind of equations that we started with over here to your normal ellipse equations, which are always going to equal 1. All right, thank you for watching.